Is the population of some fish in a pond or a dripping faucet chaotic? Well, what is chaos? In simple words, it's just the property of a system which is so unpredictable that it appears as random to us. In chaos, this is a common equation. But where does it come from? Let's consider an example of some fish in a pond. Now say the fish we have has a rate of increase of the population or growth rate of 2, which can be written as this, where x prime is the fish in the next year and x is the number of fish at present. Say that the pond can sustain a maximum of 10,000 fish. So the growth rate will be 0 when the population reaches 10,000. Hence the actual growth rate is given by this equation. Now we can also simplify the equation to this. But say we also catch some fish from the pond on a daily basis. Let it be 1% of the population. Thus the equation now becomes this, which can also be simplified as so. Now if we let 199 by 200 as alpha and minus 2 by 10,000 as beta, we will get the equation for chaos. Let's graph this with a growth rate of 2. Here's what we get. We see that the population starts low and then reaches a stable point, or commonly known as equilibrium position. We see that changing the initial population doesn't affect the equilibrium position. But when we change the growth rate, the equilibrium position changes as well. So let's make another graph of the equilibrium positions when the growth rate changes. When the growth rate is between 0 to 1, the equilibrium position is at 0. Then from 1, we have a constant equilibrium position. But when it reaches 3, the graph splits into 2. What does this mean? Well, it simply means that the population doesn't settle into a single value but rather settles into 2 values. So one year it's high, next it's low, then it's high, and so on. Furthermore, at 3.5 it splits in 4, and at 3.57 it becomes chaotic. Now if we look at the first graph, we see that the population doesn't settle into any particular position, it just changes randomly. Let's get back to the fish in the pond example. Here, if we were to change the quality of the fishing pole, it gives us a chaotic amount of fish caught and a chaotic amount of fish in the pond. Now this phenomenon is present in a very common place, a water faucet. Suppose we tweak a faucet a little bit such that the water falls in 1 drop per second. Then we tweak it a little more and it falls in 2 drops per second. Now if we tweak it to the right amount, we would get a chaotic behavior in the water droplets. A similar phenomenon is observed in a double pendulum. Well, is chaos found at rare places or is it present everywhere? Think about it, and thanks for watching.